Good morning, students. Today is Thursday, May 27, 2021. In moving forward with our algebra unit, I want to take you through some solution of equations with variables. I want to solve for the variable today and show you the algebraic way to do that. So let's get started. As always, boys and girls, a reminder, please have your notebooks, calculators, any questions we can address throughout class. We can address those in chat if we don't get them right at the beginning. Also keep in mind what we've learned about order of operations, or sometimes referred to as PEMDAS. Okay, we're going to use that today to help us solve these equations. So let's begin. Today I'm going to do a brief review. We're going to look at our new learning target. I'm going to have you folks practice, do some guided practice, and finally an exit ticket. And as always, we will do some IXL in various format. Depending on where you're at, I will expect you guys to complete some of your IXL practice today. So let's take a look and see if we remember. What would this look like? 7 less than a number 10 written as an algebraic expression. What does that mean? Well, I've got it in word form. And the goal is one of these is an accurate representation of how it would look as a numerical and algebraic operation. So take a few moments, we'll do a poll and we'll look and I'll share the results with you. Great job, students. The majority of you picked t minus 7. And if we look, as I always remind you, order is very important. 7 less than a number t. That would be t minus 7, okay? In subtraction, order, of course, is very important. That is not the same as 7 minus t. We want t minus 7. That's the best and only answer choice in this problem. If you didn't get the warm up this time, don't stress, that's fine. We'll get it next time. And hopefully the explanation illustrates why C is the correct answer. Okay? Great job, folks. Moving forward, what I'd like to do today is solve some 1- and 2-step equations, particularly focused in on fractions, equations that use fractions, because I know students sometimes have trouble with those. And we'll do that by applying properties of operations, adding, subtracting, and factoring, understanding that rewriting an expression is, in different forms can illustrate how the quantities are related, and using variables to represent quantities in a real world or mathematical problem. These are essentially word problems, guys. So let's get after it. In solving equations, one thing I want you all to keep in mind is think of it as a balance scale, okay? Just like good old Thanos, bringing balance to things. In order for the scale to remain balanced, both sides of the scale must be the same at all times. We've got the left of the equal sign and we got the right of the equal sign. And an equation, in fact, by definition means those two things are equal. When the scale is balanced, the value of each side must be equal. Let's look at an example. Maybe this will bring it into light a little bit. If you've got a simple equation like x plus 20 equals 45, well, our goal is to solve for x. What number could we substitute or plug into x to make this equation true? And I understand a lot of you might be all over the mental math, which is fine, which is okay for now. You might be saying, oh, Mr. Rose, I understand that. That's 25 is the solution I could put in there for x, and that equals 45. And that's true. I will not argue with that. However, I do want you to understand and appreciate the algebraic way we do these, because as the problems can get more complex, the algebraic way is an excellent way to do this. So here's how I would approach this problem. I would take the original problem, x plus 20 equals 45, and once again ask, what is our goal? What's our end game here? Well, we want to get the x by itself. We want to isolate the variable. Once we have the x and it's equaling something, we have our solution. So how do we get rid of the plus 20 so the x is by itself? Well, I would add a minus 20 to it. In essence, I'm doing the opposite. But remember, I got to do the same thing to the other side of the equals. So I have 45 minus 20 on the other side. What do I end up with? Well, I did exactly what I intended to do. I got my X on one side and I got 25 on the other. And as a fail-safe, I would always plug in the solution to make sure it works. 25 equals X. Oh yes, 25 plus 20 does equal 45. I'm good to go there. Now you might have noticed on the whiteboard here, I have something called SAD map. Okay, and some of my students came up with this. It's a great way to think about PEMDAS moving backwards. All right, this can be very useful. Just like we use PEMDAS, our order of operations, to solve equations, using this, think about it, since we're working backwards, can be very useful. This idea of, hey, is there any subtraction or addition in the problem? Is there any division or multiplication in the problem? So on and so forth. We'll address this more later, and we'll see in 1- and 2-step equations how this can be useful as a reminder to solve these problems. Any questions? Great job, guys. Let's keep moving. So a couple other reminders here. Steps for solving 1- and 2-step equations. We want to think inverse operations, which we address with our integers unit. You know, the opposite of a positive versus the opposite of a negative. We want to think addition is the inverse of subtraction. Multiplication is the inverse of division. Always do the same thing to both sides of the equation, meaning, again, both sides of the equal sign. And do your adding and subtracting before multiply and divide. And that's what we just addressed with the backwards PEMDAS, if you will. And here's an idea with inverse operations with an example. Okay. So X plus 13 equals 27. And once again, I understand that a lot of you say, I don't need to do the algebraic method, Mr. Rose. I know that 14 plus 13 equals 27. And that's true. But again, I want you guys to get in good habits as the algebra gets more complex. So I would do a minus 13 on both sides. And now my scales are balanced. X equals 14. Any question on what's in front of you, students? Great job. Let's keep moving. So on this one here, we've got a couple things going. I want to solve the equation. Once again, the end goal is to get the X by itself. And say, oh, wait a minute, Miss Rose, I've got parentheses in this. Right, and I provided you guys a little hint that I think will assist you on this. So I would use a distributive property to combine or simplify the 8x plus 7 or 8x plus 56 will be your end result. And then you can move forward to solve the problem. So go ahead, let's see what you all come up with on that. Great job there, students. Now, here are our dreaded fractions. I told you guys we would have these. Our dreaded fractions. What do we do when we come across something like this? You say, oh no, Mr. Rose, these are fractions. I don't like these. I understand that. But I do want you to remember, the method still stands. It's the same thing. Do recall, when you see a fraction, a number as a numerator above a denominator, all that means is what operation, folks? Good job, division. That's correct. So in essence, what I have here is C divided by 5 minus 5 equals 1. You say, oh boy, where do I begin? Well, remember, this is where the algebraic expression comes into play here. And you see that's solved for you down below. There's a nice explanation you can refer to if we're outside a live class. So I would address the addition of the 5 first. I want to get rid of that minus 5. And then what's the opposite of dividing by 5? Multiply by 5. And my final solution is 30. And remember, folks, I would always plug it back in. It's always a good fail-safe to make sure. Does that work? Does that sound right? Let's see. 30 divided by 5 minus 5. Well, let's see. 30 divided by 5 is 6. Minus 5 equals 1. Hey, that makes perfect sense. It works. So bravo. Good job. Now I'm going to give you an opportunity to practice one of these. Remember, you have your online calculator as a resource. It never hurts. I'm going to see what you all come up with on this. I'll give you a few moments and check out what you do in Pear Deck. Please ask questions along the way if you get stuck. Remember, boys and girls, I want you to try, even if you're feeling a little lost on this, I want you to give it a whirl and try and ask questions, and hopefully the explanation will help you. All right, let's take a look and see what you did. Great job, everybody. I see you applied the steps of solving an equation and our solution for X. And I think we worked that very well. We worked that through together. Now, finally, I want you all to try one completely independent on your own and see what you come up with here. We'll review and explain at the end. As a matter of fact, I'd like to give one of you students an opportunity to explain how you got your answer using our step-by-step illustration. Great job today, students. You're doing excellent. Let's look at a couple more I wanted to get the fractions out of the way first because I know how tough those can be. Let's look at a few more with integers. And it's really the same process, boys and girls. We're trying to get the variable by itself. And how do we do that? You apply inverse operations to both sides of the equal. And we see an illustration here. Just like I told you not to be thrown by fractions, don't be thrown by negative numbers. Don't let those scare you. We know how to work with negative numbers. Here's a chance for us to practice together. Here's another problem that I would like us to practice and review together. Once again, I would use a distributive property here. That will definitely help us. And notice what the question says. What are two ways to start solving this equation? Choose both ways. So I want to apply what we know about the steps here. And I just gave you a little hint too, which I'm happy to do because you guys are working hard. Try the rest on your own. Let's review. Fantastic job, students. And finally, let's see what you all come up with on this one, and we'll give it one final review. Please ask questions along the way. I'll be happy to address those. All right, let's take a look at what some of you did. Great job. I see you applying the process. If you didn't get this one quite where you want to be, don't worry. We're all in different places and we'll get you there, okay? This is our first day with this. And finally, let's practice this. What might this look like in a test situation? Let's take a look. And maybe we'll have a student guide us through how they solve this. All right, folks, one last bit of wrap up here before we leave our live session for the day. Please fill out your exit ticket. And as far as practice, what I would like you to do is go to the IXL. Now, as you know, we're all in different places. Some of you guys we have a little different how we round it out. I would like you to get to an 80 SMART score on IXL. Some of you are okay with the time of 20 minutes. And some of you are okay as long as you do approximately 20 to 25 problems. If you have any questions on that, let me know. I'll be glad to help you. You can reach out to me and we can address any further issues in class. You guys did a wonderful job today. Keep working hard and I'll see you next time. Bye-bye.